All right, so the last couple of times we've talked about CoreData, we've learned a bit about modeling. We did a bit with entity inheritance. If you remember, last time we built an app that's not Finder, it's Findest. And what we did is we built an app so that it would go through my code folder, my developer folder, and every single item that it found, it would save it into CoreData. And then we had a little Swift UI view here that was counting how many things it found. So if I run this app, let's see, we're building. And here's my app, so we're going to start scanning. And it's going to start going through my developer folder, and it's counting all of the things that it finds. And that's really cool. And it's going to find millions, because it's also looking at every Git file. Let's see. I need to pull up this window. Application support. And Findest. Go here. Just make it easy to delete. Okay. What I wanted to talk about tonight is NS Fetched Results Controller. Because what we've got here, this is the entire app, by the way. Minus the scanner itself, but this is the entire UI. And there's a lot of magic going on here in this @fetch request. It is somehow tracking all of the changes happening in CoreData. It's somehow triggering updates, and it's relaying that information back to SwiftUI so that we can put that count of values into a text, into a label. Now there might be a situation where, for whatever reason, @fetch request isn't going to be sufficient. Or maybe you're working in a part of your app that hasn't migrated to SwiftUI yet, you're still using UIKit or AppKit, and you need to do this sort of tracking and updating yourself. So what we're going to do is we're going to replace this line 21 with a different line, and we're going to use NS Fetched Results Controller instead. So if we look at NS Fetched Results Controller, this is a class that is provided by CoreData, and it is essentially a way for us to track these kinds of changes to CoreData and get told about when things change. Okay? There are a couple of fancy things that we can do with it that we'll maybe look at, but this is just part of CoreData, and it's been in since iOS 3, so you can use it.
But only macOS 10.12.
Yeah, only macOS 10.12, which is... That wasn't 14 years ago.
No, oh no, 10.12 was, I can't keep them straight now,
Yeah.
but I mean iOS 3 was like
14 years
was
ago.
like 10.8 or something.
Yeah. Yeah. I wonder what took it so long. I don't know. Okay. All right. So instead of doing @fetch request, we're going to do a different thing. We'll do. So we've got scanner. We'll create a new file, and I'm going to call this tracker. Now this thing is going to use NS Fetched Results Controller, and NS Fetched Results Controller has a delegate, and this is how it calls back to us and tells us that things have changed. And we see that the delegate, this NS Fetched Results Controller delegate protocol, requires conformance to NS Object protocol. So to keep things pretty straightforward, we're just going to make our class be an NS Object, and it will conform to NS Fetched Results Controller delegate. We'll go with having a init method here. This is actually an override. And we'll go super.init. Now, in order to integrate with SwiftUI, I'm also going to make this an observable object. And that's simply so that I can get the trigger of things changing back to SwiftUI so that things will update. So I'm going to make this an observable object. And I'm going to have a single published property count. And this will be the thing that we use in the UI instead. Yes, Andrew?
Is there a reason you're using observable object instead of the new observable?
One of the reasons is that I'm still running Ventura.
Oh. I didn't know that was allowed when you work it out.
Oh, this is my personal machine.
Still.
Also, I've not played around with the observable stuff at all.
It's easier. It's cool. But.
I question that. I like this.
For just hooking simple stuff up to Swift UI, it's easier. If you're doing like actual combined stuff, it's not easier. I think.
It's easier than at published.
You just don't even need an annotation on the account.
Okay. All right.
It's just a different annotation.
No, you don't need an annotation.
Okay, so we've got this. It's an observable object.
I still think we should see it. But you still need to add observable.
And so I'm going to comment out our fetch request line. And I'm going to put in at state object var tracker is our tracker. And here, instead of all items.count, this is going to become tracker.count. Okay? Now there's another thing. This tracker needs to know which managed object context it's supposed to be watching. Okay? So I'm going to pull that out of the environment here. Manage object context, var mock. And I'm going to put in an onAppear here. I'm going to say tracker.managedObjectContext, which doesn't exist yet.
Well, yeah, because you don't have the type.
Equals mock, and that is going to go here. Var managed object context equals nil. And import CoreData, just so it doesn't complain at me. And I think that's going to be sufficient. Yep, I am setting the context into the environment. Okay, so now if we were to run this and hit scan, it's going to start scanning and nothing's going to update because nothing's watching it and telling it to update. So that makes sense. But it compiles and runs, which is good. All right, so let's start working on our tracker. I'm going to have a private function here called build frc if necessary. And here in my did set for the managed object context, so after we are given one, I'm going to say self.build frc if necessary. And frc is short for fetched results controller, in case that wasn't obvious. All right, so here I need to actually make my fetched results controller. So let's make a spot to hold on to one, and it's going to be optional because, of course, I don't have one to start off. And it needs to know what it's tracking. Great. What did I call these things? FS items. There we go. All right, so if frc is not nil, then there's nothing to do, and therefore we have satisfied if necessary. But if we get here, then it is nil, so let's create it. So we're going to make an NSFetched results controller. And it takes a couple of things. It takes a fetch request, it takes our managed object context, and it takes this thing called a section name key path, and it takes this thing called a cache name. So let's start off with our fetch request. So I have this extension here on fs item, which we had used before, and this just creates a simple fetch request to fetch everything, because without a predicate, then it's essentially everything. Yes, give me all the things. So our fetch request here will be fsitem.all. Our managed object context, let's pull it out. So that, I guess that's another thing we should check. Guard let mock equals managed object context, else return. Call that mock. And then our section name key path, which we'll ignore for now, and our cache name, which we will also ignore for now. So this is step one. controller.delegate equals self, so that we can get told when things change. Actually, let's comment out this line first and see what happens. And then we need to say controller.perform fetch, our initial thing, our initial attempt to fetch. And now we can say self.count equals controller.fetchedObjects.count, or 0 if for whatever reason it doesn't have any. And we'll save it. Self.frc equals controller. And pretty good. Let's run it. Start scanning. And nothing's happening. Okay? This is to be expected for me. Why is nothing happening? Yes?
You're not responding to the required methods for the delegate.
Yeah, I'm not doing any sort of response to things changing. So let's kill that. Clear that. So I have the delegate here, and the delegate, let's see, ns fetched results controller delegate. There are a few different methods we can implement. We can have did change content with a diffable data source snapshot. So if you're using table views with a diffable data source, or a collection view with a diffable data source, this will, I believe, integrate well with that. Here is a similar method using a collection difference parameter. The two that I'm interested in really are controller will change content. It's a nice little heads up. And controller did change content. Those are just kind of like the basics of, hey, something's about to change. Hey, something did change. So let's implement those two. Because you'll notice that I declared conformance to the protocol, but I'm not getting any warnings. And that's because all of those protocol methods are optional. I don't have to implement any of them and it will still work. I just won't get told anything without implementing them. So let's implement them. Will change content. Here we go. And controller did change content. Okay, so actually I don't even think I need will change content. I think controller did change content. I could do self.count equals controller not fetched objects not count, or 0. I think that's it. Let's try it. Boom. That was it. Go home. No, that's really all there is to a fetch results controller. Now this is a pretty straightforward controller in that I'm not doing anything fancy with like breaking things up into sections. If you remember, like in the Contacts app on iOS, you know how things are broken up into alphabetical sections? That is what the section name key path will let you do. If you pass a parameter in here, then the information you get out of the fetched results controller will be automatically broken up into sections. And we can go take a look at what that looks like. So there is still fetched object, which is the full array of objects that you get, but it also has this array of sections, and this section will have information about what the title is and then what objects are in that section, which is really nice. And then the fetched results controller itself has other methods for converting between index paths and objects and vice versa, so that if you wanted to build one of these table views that can scrub up and down with these sections, it's pretty straightforward to do that. It's more or less mapping the table view data source methods one-to-one to the fetched results controller methods. It hooks up very nicely by design. I rarely use sections. I don't frequently build those kinds of table views, so I don't use this too much. Usually when I'm implementing a fetched results controller, it is literally this. So, yeah, that's it. Now, if we wanted to go super crazy, we could actually use this information to re-implement the fetch request property wrapper ourselves, which I think could be kind of cool. Does that sound cool?
Sure.
It does sound cool, yeah.
It does.
I have a question before you.
Yes.
Do you know if the actual fetch request property wrapper is using a fetch results controller, or did they rewrite it?
It is using a fetched results controller.
Yeah.
Yeah.
So, I've never really used the cache name. I've done
Yeah.
a lot with fetch results controllers, but anything on that that's worth?
I tried using it like once 15-ish years ago. Well, no, it can't be. It only came out 14 years ago. A long time ago, and it struggled. I think the point of the cache name is that when you're dealing with very large data sets, that it can save information about what it has found to disk,
Yeah.
so that it doesn't have to be re-hitting the underlying data store as frequently, but
It's indexed, right? So it
Yeah.
should, if you're doing your fetch request right against, you set up your predicate, so it's indexing the right thing, which it magically figures out it shouldn't have to.
I think so. Yeah. Yeah.
Can I ask a tangent question?
Yes.
More of a Swift UI question than a, core data question. But is this like a common pattern where if you have some observable object that needs information from an environment object, that you would do like a data appear and then pass it like you did?
That's the standard way of doing things. That's what like you're supposed to do. Yeah.
Cool. It just seems
Awkward.
awkward.
Yeah. Yeah, it does.
Because I ran into a case where I needed something similar, and I probably did the wrong thing because the environment object was like some singleton object, so I
Yeah.
just referenced the singleton in the class. But I didn't know, because, yeah, I've seen this before, but it does feel awkward to me.
Yep. It is, because it is.
Cool. Good. I'm glad I'm not alone. Thank you for validating my feelings.
Yeah. Questions on the tracker? This is literally it about fetched results controller. Andrew.
I just was going to add an emphasis on fetch results controller working great for this kind of thing, and you can use it. You can even just use it purely programmatically, where you're not like directly hooking it up to a UI. But it really was kind of designed for table views, to drive
It is.
table views, and it makes implementing things like updating only the things that changed instead of just reloading the whole table view easier. It makes this moves from here to here, that kind of thing easier. So it can actually do a lot more than what Dave was just
I use fetched results controller anytime I have some part of my app that wants to watch for specific changes coming from my data store. I don't even necessarily use it to drive UI, but if there's information that I want to get told about in my app, like maybe I've got a background queue like we talked about last time, importing a ton of information, and I want to keep some other stuff updated based off what I'm importing, I essentially always use a fetched results controller for this. And I've built some pretty interesting wrappers around it. Like you can turn a fetched results controller into a combined publisher if you're still using Combine, which I do. And that's really cool. You can turn them into an async sequence where it's pumping out changes. It's yielding changes as part of its sequence. What other things? I've turned them into property wrappers, which we'll do here in a little bit. They're pretty slick.
Also, they're exactly the same on Mac and iOS.
Yeah, same code, Mac and iOS.
And you get some energy, you get some memory efficiency with the context and with, you know, as was, you know, you don't need to load the whole data set.
Yeah.
That I've seen other database solutions do where it's like, really, you can tweak that fetch results.
Mhm.
So you could have 10,000 records, but you only care about the top 5 that's going to be visible. And you can tweak it such that your only memory impact is going to be those 5.
If we were to look at the actual SQL commands that were getting executed by this fetch results controller, it would be essentially 1. And it is right here when we call .count. That is going to be executing a single select count star on the underlying table. It's quite efficient. So I'm never actually loading any FS item values into memory here. So. More questions? Okay, we're going to turn this into a property wrapper. So this is less about CoreData, and now we're going to get into some SwiftUI stuff. Let's create a new file, and we need a name for our property wrapper. Let's call it
Property wrapper.
tracked objects. Sure, whatever. And we're going to import SwiftUI, and we're going to create a property wrapper called tracked objects. And by itself, this is not sufficient. If we want it to play nicely with SwiftUI, we need to conform to a property or a protocol called dynamic property. Now there are a couple things we're missing. One, it doesn't know what it's tracking. And 2 is it needs a wrapped value. All property wrappers need a wrapped value. And ours is just going to be the int. So we'll just call that int 0.
Is that a key? Is that part of the property?
Yeah, so all property wrappers require a wrapped value property. And then they also may have another thing called the projected value. And I'll just make this a string for illustration. And this, the projected value, this is the $ syntax. When you access the $ of a @state or @state object, you're really retrieving the projected value of the property wrapper. It's not a binding. It's just that the state property wrapper's projected value is implemented to return a binding value. Does that make sense? So if we go look at state in SwiftUI, it's a property wrapper, conforms to dynamic property, which we'll talk about in a bit. But here is its wrapped value. It returns whatever it is it's holding. And then it has a projected value, which returns the binding. And binding itself is a property wrapper, so that's why you can use @binding in SwiftUI. But there is nothing magical. Well, there's a lot magical about the $ syntax. But there's nothing inherent about the $ syntax that requires you to use a binding with it. Okay, it's just another thing on the property wrapper. Make sense? We're not going to use a projected value for now. Now, when you have a property wrapper that conforms to dynamic property, SwiftUI is going to look at it and start tracking it for changes. And if it sees changes coming out of this dynamic property wrapper, it will use that to rebuild your UI. Okay? However, we don't have good ways of triggering those changes manually. However, SwiftUI will recursively dig through property wrappers to figure out what it should track. So what we can do instead of manually triggering changes is we can use another property wrapper inside of our property wrapper. And if we can make that property wrapper trigger changes, then our property wrapper will trigger changes and Swift UI will update. Okay? So, tracker. All right? And now our wrap value, instead of being equal to 0, is going to be our tracker.count. Okay? But remember, we still need that managed object context, right? This is the other part of dynamic property, and this is fundamental to how SwiftUI works. SwiftUI goes through a couple of different phases as it's constructing your UI. And one of the first phases is called updating, and then after everything has updated, then it retrieves the body of your view. And then after it retrieves the body of the view, it builds it, puts it up on the screen and all that stuff. Dynamic property is a protocol that allows you to implement the update method. So you have a chance to get everything in place and ready to go before the view's body is called. Okay? So let's use that. Func update. Now here we need to say tracker.managedObjectContext equals something, right? Well, where are we going to get the managed object context from? Where did we get it before? The environment. So let's use another property wrapper. Boom. By the time our update method is called, all of the other property wrappers and everything else that we depend on will have already updated, which means that the environment property wrapper will have already received the managed object context value so that when our update method is called, we can go grab it. And when our update method is called, we can grab it, give it to our tracker so that when the view's body is called, the tracker's fetch results controller has been built and is starting to track changes. There's a lot of hops going on here. But this, as is, will work. So if we go back here to our content view, I'm now going to comment out that stuff. I'm going to comment out that thing. And I'm going to put in @tracked_objects var item count. And I don't even need a type on this because it already knows the type. It says, oh, tracked objects always just give you an int. I'm going to change this now to item count. Build succeeded, that's a good sign. Let's go clear the database, boom, run, and, oh, publishing changes. Oh, yes, I know why. We'll talk about that in a second. And scan, boom. And this is because SwiftUI is looking in our property wrapper, sees that it holds a state object, and it's saying, aha, whenever that state object publishes changes, because it's an observable object, I'm going to use that to cause a rebuild of the place where that state object is used. So you can use this to implement your own property wrappers. And look how easy that was.
Easy code-wise.
Yeah, I mean, like, yeah, conceptually there's a lot going on here.
There's some mental gymnastics.
Yes.
At least for me.
But this is 10 lines of code. Less if we want to get crazy with white space. I think this is really cool. So we have recreated the fetch request property wrapper. You could now imagine that instead of just always using tracked objects here, we could make it generic, and we could say like fetch result, request result. You know, we could make it say this has to be some sort of generic type, and like maybe we've got to pass in a fetch request, because you know, if we go and we look at fetch request, that's exactly what it's doing, right? It's generic to some result type, which is an NS fetch request result. And when you initialize it, scroll, like you can pass in an entity and sort descriptors, or you can pass in the fetch request. Like there are just all these different things you can do. Like this is literally how fetch request is implemented. Is that under the hood, it's got its own observable object that's wrapping up the fetched results controller. It's using this sort of recursive property wrapper thing to cause trigger changes, and yeah, there we go. Cool, huh? So, a way you might use this is fetch request, the property wrapper fetch request always gives you multiple results, right? It gives you a fetched results, which is 0 or more things. You could write a property wrapper, let's call it struct fetch 1 result, that is a NS fetch request result, dynamic property, that itself wraps a fetch request. Result like this. And for its wrapped value, returns the request dot first. So you could do something like that. And there's more you would need. You would need, you know, like some initializers here. But if you wanted a nice way to say, like, I know I want to request the object in my CoreData store that has this particular ID, and I don't want to have to deal with getting back an array of results, you could do it like this and implement, you know, some sort of init identifier, you know, UUID, and use that to construct your fetch request, save it in your fetch request property wrapper, and there you go. Make sense? Cool. Questions? Yes?
What was up with the error?
Which
Like,
error?
Oh, I know what that was about.
Oh, the error, right. So I talked about the two phases, right? There's update and then building the body. While you're inside the update method, and also technically while you're inside your body, you are not allowed to indicate to SwiftUI that something changed. And because SwiftUI would say, oh, you know, something changed, I need to rebuild again. But then while it's rebuilding, it says, oh, something changed, I need to rebuild again. And so to prevent that, it logs this error. Publishing changes from within view updates is not allowed. This is undefined behavior. And in fact, you can even see this over here. And this is the line that is the problem. And the problem is because of this.
Yep.
When we update our custom property wrapper, we're setting the managed object context, right? That's going to call the build FRC if necessary, which is going to call the fetched results controller, which is going to perform the fetch, and it's going to change the published property. A way to fix this is to make this not be published. Let's just do like private set for good information hiding practices. And then this is not going to do anything, but now there's nothing telling SwiftUI that something has changed, right? Because at publish automatically triggers the object will change publisher. Well, look, controller will change. Self.object will change.send. Now it works exactly the same, no errors, and I'll prove it to you. And scan, no error.
Do you know why the updates to the label get progressively farther apart?
Probably because I'm not scanning very intelligently. I'm doing like a recursive scan where it hits a folder, it scans all of the top level items in that folder and then saves it.
Oh, okay.
And so if it hits a folder with like bazillions of things in it, like say a .get folder,
Yeah.
then it's going to pause until it gets
Until
all
it
of them.
finishes the whole
Yeah.
folder.
Oh, so it's not that it's progressively getting slower, it's just slowing down, it hits a big folder.
It hits a big folder.
Gotcha.
Yeah. And I think if we were to check out the CPU monitor, we would see that's the case. Like, we'll see it stay high and doing stuff even though the label's not updating, and it's because I'm pretty sure it's hitting these massive folders. So, that's why.
Cool.
If you want to go really a lot deeper into this, I've actually written a couple blog posts about this. So if you go to davedelong.com and then go to blog, and then I find stuff on archive here. I have two articles here, CoreData and SwiftUI and custom property wrappers for SwiftUI. So what I just talked about with the custom property wrappers is in here, and it talks about, you know, using dynamic property and encapsulating another property wrapper that SwiftUI will track. And then I talk about a couple things that I've built with this, like app feature or app settings and so on. And then CoreData and SwiftUI is where I talk about some of the ways that I have integrated CoreData into my SwiftUI projects. And I have like a whole other layer that I build on top of it so that all of the values that I get are structs instead of managed objects. And I've got property wrappers that I talk about for it. So that's these two articles, these two posts right here. Questions?
You know how in your custom property wrapper you had a state object, another state object?
Yeah.
Because there's not a good way to. The question is, like, how does app fetch request do that? Is it having to do the same thing, or is there some?
Yeah, the fetch request holds a state object.
Okay. It's kind of annoying. It's kind of weird.
It's when you get down to it, it's not doing anything magical. Like they're
Well,
not
yeah,
using
it's
like private
just-
APIs
It's just that
I'm
publisher.
aware of.
Yeah, sure. Right.
This is just like obscure parts of Swift UI that most people don't even realize is possible. That you can, like, people of course know about property wrappers, but the art, you could say, of building a property wrapper that integrates with Swift UI is not well known.
How did you figure it out?
I don't even remember. There was one point where I was looking around in the source code trying to figure out how they worked, and I kept on seeing this pattern over and over, and so I tried it and it worked. So.
Well, the reason I asked you that is because I wanted to figure out if I was just dumb and missed where they documented that or something, but if you were looking at source code, I don't feel bad.
It's possible it got documented. Dynamic property. Yeah, that's really unhelpful. Yeah, it's entirely possible it came up in WWDC presentations. I am about 6 years behind watching WWDC videos, so I don't know.
I haven't watched all of them either, so I can't.
But I blogged about it, so there's some
Yeah,
documentation.
yeah, that's good.
Yeah.
Can I ask a property wrapper question?
Sure.
So if you don't have, like in this tracked objects property wrapper, a projected value, what happens when you do the dollar sign on the tracked objects?
Let's try it. Item count. Can't find it in scope.
Fair enough.
But we can go at it here. And let's just have it be the stringified wrap value. And now it builds. No errors. And we run. Boom, logs a 0. Woohoo! Because it's on a peer, so it's only getting happening once before it's done anything.
But it's a binding now.
No.
No! It's a projected value. Yeah. Other questions? No? Okay.